Hey everyone, welcome back for another deep dive. Today we're tackling AI replication, specifically all the buzz around folks trying to copy OpenAI's O1 model. And, the big thing everyone's talking about. That O1 is a whiz at solving really tough math problems. And guess what? You sent over this super interesting research from the Generative AI Research Lab. They think they've found a potential shortcut. They're calling it knowledge distillation. Could be brilliant, but also kind of worrying. It's almost like instead of learning how a master chef makes their signature dish, you just taste it and try to recreate it based on the flavors, you know?
That's a really good analogy. So in this scenario, OpenAI's O1 is our master chef, right? Is cooking up these solutions to complex math problems. Then researchers are basically feeding those solutions to another AI, the student, and training it to solve those same kinds of problems.
Right. And here's the crazy part. This student AI, even with this kind of simpler training, can sometimes beat the publicly available version of O1 on crazy hard math problems. Like, we're talking American Invitational Mathematics Examination, the AM. I can barely figure out my tips at a restaurant, and this AI is crushing AIM problems.
Yeah, it is. It's pretty amazing. But the researchers are raising some really important questions about this shortcut approach. And one of the most interesting things they point out is that a lot of teams might be using this knowledge distillation thing without actually admitting it.
Oh, really? So kind of sneaky.
Yeah, and that lack of transparency, it makes it hard to actually know what's real progress in AI and what's not. It's like judging a cooking competition where some chefs are secretly using pre-made stuff, you know?
Totally. Like, how can you even say it's a fair competition, though? How do you know who's really innovating?
Exactly. And that's a big worry. This lack of transparency could even slow down innovation in the whole field. Because if everybody's just focused on tweaking these existing models, who's going to come up with the next big breakthrough?
Okay, I get that. But when you still learn something by trying to recreate, like, the master chef's recipe, even if you don't make something totally new, you're still got to figure out some of their techniques, right?
Yeah, that's true. But there's always that risk that people get too reliant on these shortcuts. They might stop looking for totally new approaches, new ways of doing things, which could be even more powerful, you know? Plus, there's another thing. The student can only ever be as good as the teacher. So if a model is trained just on what O1 can do, it might never be able to truly surpass O1.
That makes sense. It's like relying on a recipe forever. Even if you get really good at cooking, you might never create your own signature dish.
Exactly. And this whole reliance on shortcuts, it could really impact the future AI researchers.
In what way?
Well, think about it. If they're not learning the really fundamental problem-solving skills, the skills you need to build AI from scratch,
Right.
then that can hold the whole field back.
It's like giving someone a calculator before they even know basic math, right? They
Yeah.
might get the answer, but do they really understand how they got there?
Yeah, that's a great way to put it. And because of all these concerns, the researchers are proposing something called the Technical Transparency Index.
Okay, what is that?
So it's basically a framework to evaluate how open and reproducible these different O1 replication projects really are, which is super important because it means you can actually see how trustworthy your research project really is, you know?
So it's like a scorecard for honesty and openness in AI research. I like
And
it.
so hold on, before we dig into that index, there was another super interesting finding in this research. Apparently, training AI on all these tricky math problems, it can actually make the AI better at other stuff too, not just math.
Yeah, this is a really surprising discovery. What they did was they created a special data set of O1's long thought solutions. Long thought.
Yeah. Basically, it's how the AI broke down the problem step by step, like a human would, you know? And then they used this data set to fine-tune an existing language model.
Wait, so they taught an AI to think through problems like a math whiz, and that somehow made it better at other things too. That sounds almost too good to be true.
It does sound pretty wild, right?
Right.
But the results are really interesting. This fine-tuned model, it got better at general reasoning. It was less likely to give, harmful or biased answers.
Yeah.
And it even had fewer of those weird AI hallucinations we hear about.
Hold up, hallucinations. Like the AI is making stuff up.
Yeah, it happens more often than you think. But in this case, this fine-tuned model actually started to, fact-check itself, even though it couldn't actually access the internet. It's almost like it developed a healthy sense of skepticism.
No way. So this AI can solve crazy math problems, it can reason better, avoid bias, and it can even fact-check itself. It's like the ultimate student.
Yeah, it's pretty impressive. And the research has some really interesting case studies to show how these improvements actually work in practice.
Oh, I definitely want to hear about those. Give me the details.
Okay, so one example focuses on safety. Let's say you ask the AI for advice on preventing, like, electric bike theft from your building hallway. The initial model, before it did all this fancy math training, it focused only on security stuff, like locks and alarms.
I mean, that's what I'd probably think of.
Exactly.
Yeah.
But here's the thing. It completely missed a huge safety risk. It didn't consider the fire hazard of charging an electric bike in a hallway.
Oh, wow, you're right. I didn't even think about that. That could be really dangerous.
Yeah, especially in, like, a crowded building. But the model that went through the long thought training, the one that learned to think like a mathematician, it actually highlighted the fire risk first. It focused on safety regulations and thinking about, like, everybody in the building, not just the person asking about their bike.
Wow. So the AI is basically saying, hey, I know you're worried about theft, but let's think about everyone's safety first. That's pretty cool. It's like it can think beyond the immediate problem and see the bigger picture.
Yeah, it's a big shift. It even suggested other solutions, like designated charging areas or community bike sheds with better security. It's like it went from being a security guard to, like, a safety consultant.
Okay, that is seriously impressive. What other examples were there?
Well, there's this other one that shows how this model got better at avoiding those hallucinations. They asked it to figure out who won a specific award back in 2010. The model without the math training. It tried to pretend it could access the internet and research databases to get the answer. It even described the whole research process, even though it couldn't actually do any of that.
So it was basically making stuff up to sound smart, kind of funny, but also a little scary, right?
Exactly. But get this. After the fine-tuning, the model just said it had done the research and found the answer. It recognized that it had limitations,
Yeah.
which is a huge step in building more trustworthy AI.
Okay, so it's learning to be more honest about what it does and doesn't know. That is definitely a good thing. But were there any examples where it actually caught itself making a mistake?
Yeah, actually, there's this great example. They gave the model a prompt with a false premise. It claimed that a certain river in China was the second longest in the country, and then asked for the river's local name.
Oh, sneaky.
Yeah, they were trying to trick it. The initial model totally fell for it and tried to answer the question based on that wrong information.
Yeah.
But the fine-tuned model, it actually pointed out the mistake. It gave the real name of the second longest river and then answered the question using the right info.
Wait, the AI fact-checked the prompt? That's wild.
It is. And it went even further. It started talking about why someone might have made that mistake about the river, mentioning things like economic importance and water flow. It was trying to understand how someone could get it wrong in the first place.
Okay, that is mind-blowing. So it's
Yeah.
not just correcting the error, it's trying to figure out why the error existed.
Exactly. And all this just from training on math problems. They also tested how this math training affected the model's ability to handle more general knowledge questions. And the results were really good.
So it wasn't just good at math, it got smarter overall.
Exactly. They gave it a bunch of general knowledge questions, and it did really well. For example, they asked it a technical question about programming in Python.
Programming. Not really my thing, but tell me, how'd the AI do?
Okay, so they asked about a specific function in Python called asyncio.sleep. It's a way for programmers to make sure different parts of their code don't conflict when they're running at the same time, which is especially important for AI systems, right?
Okay, so it's like making sure everyone in a band is playing in sync.
Perfect analogy. So the initial model gave a decent answer, but it was pretty basic. Kind of like, here's what this function does, and that's it.
Okay, not super helpful.
Right. But the model that had the math training, it gave a much more detailed and helpful response. It explained the function, but it also went into more advanced stuff, like debugging techniques, managing different parts of the code, potential problems to avoid.
So it's like it went from being a beginner programmer to someone who really understands how to build these complex systems.
Exactly. And remember, this was all from training on those complex math problems, not on programming specifically.
You're telling me that learning to solve really hard math problems could make you a better programmer, even if you've never written a single line of code.
It seems that way. It suggests that training on these complex reasoning tasks, even if it's just in one specific area, it can make a model better at handling all sorts of general knowledge and problem solving.
So it's like a mental workout for the AI. The more it uses those reasoning muscles, the stronger it gets overall.
That's a great way to think about it. Now let's circle back to that technical transparency index we talked about. Remember, it's that framework they developed to assess how open and reproducible these different O1 replication projects really are.
Right. The scorecard for honesty in AI research. So what does it actually look at?
It focuses on four main things: data transparency, methodology transparency, evaluation transparency, and whether they make their resources open source.
Okay, break that down for me. What does data transparency mean?
It basically means being upfront about what data they use to train and test the model, where did it come from, how is it collected, and, importantly, can other researchers get access to that data to check the findings.
Got it. So no shady data.
Exactly. Then there's methodology transparency. That's all about clearly explaining how the model was developed and trained. What algorithms did they use? What were the specific training steps? It's like giving someone a detailed recipe so they can try to replicate what you did.
Okay, so no secret ingredients.
Right. And evaluation transparency means being open about how they tested the model.
Makes sense.
What benchmarks did they use? How did they measure performance? And was it all done fairly and without bias?
So we know how the AI actually performs in the real world, not just in some perfect test environment.
Exactly. And lastly, there's the question of open source resources.
Right.
That means making their code, models, and data sets publicly available. So other researchers can look at the code, run their own experiments, and maybe even build on what's already been done.
Got it. So it's like sharing your lab notes and equipment with other scientists so they can learn from you.
Exactly. The researchers actually used this technical transparency index to look at a bunch of existing O1 replication projects. And guess what they found?
I'm guessing some teams were more open than others.
You got it. Some teams were super detailed and made everything public, while others were much less transparent.
Okay, so there's definitely room for improvement in terms of openness in AI research.
For sure. And this technical transparency index is a great tool to encourage more transparency and accountability.
Right, because ultimately we all benefit from more trustworthy AI research.
Absolutely. Now, even though this knowledge distillation technique has been really effective for copying AI capabilities, there are some potential downsides to relying too heavily on it.
Oh, so it's not all good.
Well, like with any shortcut, you gotta think about the trade-offs. The researchers argue that over-reliance on knowledge distillation could actually lead to stagnation in the field.
Really? How so?
Well, if everyone is just focused on copying models like O1, they might not be as motivated to explore totally new approaches, new algorithms.
We get stuck in a rut just copying what's already been done.
Exactly. And remember, models that are trained through distillation can only be as good as the original teacher model, which is O1 in this case.
Right, that performance ceiling.
Exactly.
Yeah.
So even if you get really good at copying, you're still limited by what the original model could do. And the researchers are also worried what this could mean for future AI researchers. If all they learn is how to tweak existing models, they might miss out on developing those really deep problem-solving skills that you need to create truly groundbreaking new AI.
So it's like teaching someone to paint by numbers, but never letting them experiment with their own colors and techniques.
Exactly. They might be able to make a decent painting, but they'll never become true artists.
Right, because real innovation comes from understanding the fundamentals and then pushing beyond them.
Exactly. And that's why the researchers are calling for a more balanced approach, one that combines those practical benefits of knowledge distillation with a strong focus on fundamental research and developing new algorithms.
So not ditching the shortcut completely, but using it wisely.
Exactly. They're saying that we need to train a new generation of AI researchers who are not just good at copying, but who are also true innovators.
Because at the end of the day, we need both, right?
Yeah.
People who can build on what's already been done and people who aren't afraid to take risks and explore the unknown.
Absolutely. And the researchers summed it up perfectly in their paper. They wrote, "Building intelligent AI is crucial, but cultivating human minds with first principles thinking is our ultimate mission." They are, after all, the true architects of AI's future.
Wow, that's powerful. It reminds us that even though AI is becoming incredibly advanced, it's still something created by humans. And the future of AI depends on us being able to think critically, creatively, and ethically about how we develop it.
I couldn't agree more.
This has been an amazing deep dive. We've talked about a potential shortcut to AI development, its pros and cons. We've seen how training on complex reasoning tasks can make AI better at all sorts of things. And we've explored how important transparency and open collaboration are in AI research.
It's been a pleasure exploring these ideas with you.
And before we wrap up, I have a question for you, the listener. What are your thoughts on this balance between making quick progress and focusing on long-term innovation in AI research? Is a shortcut like knowledge distillation worth the potential risks? We'd love to hear your perspective.
Okay, so let's dive into some of those case studies the researchers provided. They're pretty fascinating. One example really highlights how this training impacts safety. Imagine you ask the AI for tips on how to prevent, say, electric bike theft from a building hallway. The initial model, before the math training, it zeroed in on security measures, like locks and alarms.
Makes sense, right? I mean, that's the first thing that comes to mind.
Right. But here's the thing. It completely missed a huge safety issue. It didn't even consider the fire hazard of charging an e-bike in a hallway.
Oh, wow, yeah. Didn't even think of that.
Right. Especially in a crowded building, that could be a real problem.
Definitely.
But the model that was fine-tuned with the long thought data, the one trained to think like a mathematician, it actually brought up that fire risk right away.
No way.
Yeah, it emphasized safety regulations and the well-being of everyone in the building,
Yeah.
not just the person asking about their bike.
Wow, so the AI is basically saying, hey, I know you're worried about theft, but let's think about the bigger picture here. That's amazing. It's thinking beyond the immediate problem.
It really is.
Yeah?
It even suggested things like designated charging areas or community bike sheds with better security. It's like it went from being a security guard to like a full-blown safety consultant.
That is so cool. Okay, what other examples did they have?
Well, there's another one that shows how the model got way better at avoiding those AI hallucinations we talked about. They asked it to find out who won a specific award back in 2010. The initial model, the one without the math training, it basically tried to make it seem like you could access the internet
Yeah.
and research databases to find the answer.
Oh, really?
Yeah, it even described this whole research process, even though it couldn't actually do any of that.
So it's making stuff up to sound smarter.
Pretty much.
I mean, it's kind of funny, but also a little worrying, right?
Yeah, definitely.
Yeah.
But the cool thing is, after the fine-tuning,
Mhm.
the model just admitted that it didn't have the answer. It acknowledged its limitations.
Okay, so it's learning to be more honest about what it knows and doesn't know. That's reassuring. But were there any examples where it actually caught itself making a mistake, like in real time?
Yes, there's this great example. They gave the model a prompt that included a false premise. It said that a certain river in China was the second longest in the country. And then it asked for the river's local name.
Ooh, tricky.
Right. The initial model totally fell for the trap and tried to answer the question based on that wrong info.
Mm-hmm.
But the fine-tuned model, it actually pointed out that the prompt was wrong. It gave the actual name of the second longest river and then answered the question based on the correct information.
Hold on, so the AI fact-checked the prompt itself.
It did.
That's incredible.
It is. And it didn't stop there. It even went on to discuss why someone might have made that mistake about the river in the first place, talking about things like economic importance and water flow.
Wow, so not only is it correcting the mistake, it's also trying to understand where that mistake might have come from.
Exactly. And remember, all this just from training on math problems. They also wanted to see how this math training affected the model's ability to answer more general knowledge questions. And the results were really positive.
Interesting.
Yeah, they gave it a bunch of general knowledge questions and tasks. For example, there was this one about programming in Python. Have you ever done any programming?
Not really. Definitely more of a words person, but I'm curious, how did the AI do?
Well, they asked a pretty technical question about a specific function in Python called asyncio.sleep. It's a way for programmers to make sure different parts of their code run smoothly without clashing. It's especially important for AI systems that need to do lots of things at the same time.
Oh, okay, so it's like making sure everyone in a band is playing in sync.
Exactly. So the initial model gave a decent response, but it was pretty basic, just a surface-level explanation. But the fine-tuned model, its response was much more in-depth. It not only explained the function, but it also went into more advanced topics like debugging techniques, managing different parts of the code, potential pitfalls to avoid.
So it's like it went from being a newbie programmer to someone who really gets how to build these complex systems.
That's a great way to put it.
And all this from training on math problems, not programming.
Right.
So are you saying that learning to solve really hard math problems can actually make you a better programmer, even if you've never written a single line of code?
It seems that way. It suggests that training on complex reasoning tasks, even in one specific area, can boost a model's ability to handle all sorts of general knowledge and problem solving.
So like a mental workout for the AI.
Exactly. Okay, now let's circle back to that technical transparency index we mentioned. Remember, that's the framework the researchers developed to see how open and reproducible these different O1 replication efforts are.
Right, the honesty scorecard.
Exactly. So it looks at four main aspects: data transparency, methodology transparency, evaluation transparency, and whether the resources are open source.
Okay, break that down for me a bit.
Sure. Data transparency means being upfront about what data was used to train and test the model. where it came from, how it was collected, and whether other researchers can access it.
Got it. So no mystery data.
Right. Then you have methodology transparency, which is all about clearly explaining how they developed and trained the model, what algorithms were used, specific training steps, that sort of thing.
Okay, so like a recipe, but with no secret ingredients.
Exactly.
And what about evaluation transparency?
That means being clear about how they evaluated the model, what benchmarks were used, how they measured performance, and whether the process was fair and unbiased.
Right, so we know it can perform in the real world, not just in a perfect testing environment.
Exactly. And finally, there's the issue of open source resources. That means making the code, models, and data sets publicly available, so others can look at the code, run their own tests, and maybe even build on the work.
Okay, so it's about encouraging collaboration and transparency.
Precisely. Now, the researchers actually applied this technical transparency index to several existing attempts to replicate OpenAI's O1. Well, there was a pretty wide range in terms of how transparent these different teams were. Some were super detailed and open, while others, not so much.
Sounds like there's definitely room for improvement in the AI research community.
Definitely.
Cool.
But this technical transparency index is a great step towards encouraging more openness and accountability.
Which ultimately benefits everyone, right?
Exactly. Now, while this knowledge distillation thing has been really effective for replicating AI, there are some potential downsides to relying too much on this approach.
Oh, so this shortcut isn't all sunshine and roses.
Well, like any shortcut, there are trade-offs. The researchers argue that over-reliance on knowledge distillation could lead to a kind of stagnation in the field.
Interesting. How so?
Well, if researchers get too focused on just mimicking existing models like O1, they might be less likely to explore completely new approaches, new algorithms and stuff.
So it's like we get stuck in a rut just copying what's already been done instead of coming up with something new.
Precisely. And remember, models trained through distillation can only ever be as good as the original teacher model, which in this case is O1.
Right, that performance ceiling we talked about.
Exactly.
So even if you become a master of copying, you're still limited by what the original model could do.
Exactly. And the researchers are also worried about what this could mean for future AI researchers. If all they learn is how to tweak existing models, they might not develop the really deep problem-solving skills needed to build truly groundbreaking AI.
So it's like teaching someone to paint by numbers, but never letting them experiment with their own colors and techniques.
That's a great analogy.
Yeah.
They might be able to create a decent painting, but they'll never become a true artist.
Right, because real innovation comes from understanding the fundamentals and then pushing beyond them.
Exactly. And that's why the researchers are advocating for a more balanced approach, one that combines the practical benefits of knowledge distillation with a strong emphasis on fundamental research and developing new algorithms.
So not abandoning the shortcut entirely, but using it wisely.
Exactly. They argue that we need to cultivate a new generation of AI researchers who are not just skilled replicators, but bold innovators.
Because at the end of the day, we need both, right?
Yeah.
People who can build on what's already been done and those who are willing to take risks and venture into uncharted territory.
Absolutely. And they actually sum this up beautifully in their paper. They wrote, building intelligent AI is crucial, but cultivating human minds with first principles thinking is our ultimate mission. They are, after all, the true architects of AI's future.
Wow, that's a powerful statement. It's a good reminder that as incredible as AI is becoming, it's still a tool created by humans.
It is.
And the future of AI depends on us being able to think critically, creatively, and ethically about how we develop it.
I couldn't agree more.
Yeah, it really makes you think, doesn't it? Like, what does it even mean to be innovative in a field like AI? Things are changing so fast.
It's a great question for sure. This paper really makes us think about the core values that are driving AI research,
Right.
Are we too focused on just getting results, on building AI that can beat humans at specific tasks? Or are we actually investing enough in helping AI truly understand things, in making it able to reason and learn and adapt in ways we can't even imagine yet?
It's like we're all caught up in this race to build the fastest, smartest AI, but have we stopped to ask ourselves, what kind of future we're actually building towards? Are we creating tools that'll help us solve the world's problems, or are we, accidentally creating something that we won't be able to control?
Those are some big questions. And yeah, there aren't easy answers, but this research is a good reminder that we can't just hand over all the responsibility to the algorithms, We need to be involved in shaping the future of AI, making sure it actually aligns with our values and that it's actually benefiting humanity.
And that all starts with asking the right questions, doesn't it? Like the researchers did in this paper. They didn't just focus on the good stuff about knowledge distillation. They also pointed out the potential problems. And they basically challenged the AI community to be more open and accountable.
Exactly. They understood that real progress in AI isn't just about like building more powerful models. It's also about fostering a culture of open discussion, critical thinking, and a real commitment to ethical development.
And it's not just on the researchers and the developers, right? It's on all of us. We need to stay informed. We need to talk about these things. And we need to make sure that AI is developed in a way that benefits everyone.
Couldn't agree more.
So before we sign off, I really encourage everyone to check out this full research paper from the Generative AI Research Lab. It's a really interesting read, and it'll definitely give you more to think about.
Definitely worth a read. And remember, the future of AI, it's not set in stone.
Right.
We're all creating it right now through the choices we make, the questions we ask, and the conversations we have.
Well said. So keep those questions coming, keep exploring, and keep thinking critically. The world of AI is full of amazing possibilities, but it's up to us to make sure those possibilities lead to a better future for everyone.
Absolutely.
And that's a wrap for this episode of The Deep Dive. Thanks for joining us on this journey into the world of AI replication. We'll catch you next time for another deep dive into the amazing world of knowledge and discovery.